Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Modeling variation problems are actually very simple as long as you understand how to read them. You are going to have three options: direct, inverse, or joint. Joint is just a combination of direct and inverse, so you just need to understand that joint is when it becomes more complicated. A quick note, modeling variation will only have one of two formats: y equals k times x, y equals k divided by x, and then joint are things like y equals k times L times W, y equals k over, or kx over z squared, etc. Okay, so you'll notice that every single one of these has a k in it. Okay, k is our constant of variation. And you'll also notice that there is no plus or no minus. If there is a plus sign or a minus sign, you no longer have direct or inverse variation. Okay, so what is direct variation? You actually see direct variation a lot. Think about it like your hours versus your pay. Your constant of variation in that much is how much money you get per hour. Maybe it's your gallons of fuel versus the cost. So it will pass through 0, 0, but as one goes up, the other goes up. Or as one goes up, the other goes down. An inverse variation might be like you filled up your car and it's currently full and you start driving it. So the more miles you drive, the less fuel is in the tank, obviously until your next fuel up. So as miles goes up, your fuel goes down. So those are going in opposite directions. If you're ever given a table of values, you just have to check. Does it fit as something times x or something divided by x? So again, if I'm given a table of values, let's say I'm given 2, 3, 5, right? And I get 10, 15, and 25. Well, we can see that if I were to do 5 times each of these, I would have each of these. Therefore, this is a direct variation because they can be written as the equation y equals 5 times x. Our constant variation is 5. And you could test the same for inverse. So how might they write the problems? Well, sometimes they write them as very complicated word problems. And I will do an example of one of those, but we're just going to do one example of each. So they might start off, suppose y varies inversely to x and y equals 2 when x equals 8. Find y when x equals 12. Okay, so I color-coded that in 3 different colors. Obviously, your book is not going to color-code it. So what's in black just literally tells us we are starting off with k divided by. Inverse means reciprocal, so that's why instead of multiplying by x, we're dividing by x. Okay, so now I'm going to do the purple. I'm going to literally substitute 2 for y and 8 for x. Okay, I can now see that k must be 16. So I'm going to go back and amend my original. Y equals 16 over x. Now I'm going to move in and find the blue. Find y when x is 12. Oh, well, that's 1 1/3, or 1.3 repeating. So it's not a big deal as long as we know our vocab words. We can, the black was what we wrote down because of our vocab words. The purple is what we utilized to find k. Now we have our equation written, now we can apply it. So read the vocab, solve for k, apply it if necessary. They might sometimes just stop and say, hey, write the equation. Sometimes they're going to have you actually assess something else. So if y varies jointly with x and z, and if y equals 20, when x equals 2 and z equals 5, find y when x equals 14 and z equals 8. So jointly could include multiplying and dividing. It could just be multiplying, it could just be dividing. So read carefully, but assume multiplying unless you ever see the word inversely. If you see the word inversely, that's when we divide. The word inversely never pops up, so we are going to assume multiply. So blah, 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 blah. Y equals, we need our constant. You only get one constant per problem. XZ. Boom. 20 equals something XZ. Okay, well 2 times 5 is 10. So K must equal 2. So now I'm going to rewrite now that I know it. Well, this isn't bad. Find y when x is 14 and z equals 8. There's our last step. Find y when x is 14 and z is 8. I wrote z. There we go. Well, now we just need to grab that handy dandy calculator, right? And we've got 2 times 14 times 8. 224. And we would be done. So if we say y varies directly, it's the same thing. We just do a multiply, right? So let's say we know it varies directly. We know x equals 6 goes with y equals negative 16. So y equals 12 goes with what x value? Now I kind of switched this up a little bit, right? 1, I just kind of gave you the information. 2, let's go through step by step. We've written out the equation. We're going to substitute this like an ordered pair to solve for k. So negative 16 equals k times 6. Divide both sides. So k will equal negative 16 divided by 6, which is negative 8 over 3. And I like leaving it as a fraction. So y equals negative 8 over 3x. But now they've given us y is 12. So 12 equals negative 8 over 3x. So how to solve? We're going to divide or multiply by the reciprocal. 12 times negative 3/8 will give us x. And that'll be negative 36 over 8. They both divide by 4, so negative 9 over 2. So, or you can type it in a calculator, right? So the hardest thing to remember is that when I see direct, I multiply. When I see inverse, divide. So how could this look like in a complicated situation? And what about if they don't actually give us values? So the apparent brightness B of a light. Okay, so they're telling us one of the variables is B. The apparent brightness B of a light, and it's a light source, sorry, measured. Now, they like to give us extra information sometimes, in watts per meter squared, is directly proportional to the luminosity, L, measured in watts. Of the light source. And inversely proportional to the square of the distance d from the light source. And that's going to be measured in meters. Okay, so let's write an equation. Okay, I forgot my T on apparent. So there's a lot of extra words here. So the apparent brightness B is directly proportional. That means varies directly. Okay, so B equals K times L. And inversely proportional, divided by the square of distance. There we go. So a lot of words there, and we only really needed what I underlined in blue. Okay, so think about this. If you have a bright light bulb and your distance gets closer, or so think about just any light bulb, and as you move closer to it, doesn't it get really a lot brighter to your eye? Versus as you move further away from it, you can think of like headlights. Versus what if you change the number of lumens in it? Like if you increase the lumens, won't that also appear brighter? So changing your distance, like shortening your distance, makes it brighter, or changing your lumens also makes it brighter. So let's think about a set of headlights, okay? And the headlights are coming at us. And let's see how much brighter they are comparing the distance of 50 meters to 100 meters, right? So comparing like 100 meters away versus 50. Or actually, let's just go with any meters versus half, like they cut the distance in half. What effect does that have on us? So we're going to take that same B equals K times L over D squared. But we're going to compare the original to what happens after I've cut this in half. So I want to clear out those parentheses. So that would be the same as, so I need something, it's going to do something to the brightness. It's going to multiply the brightness by something. It might multiply it by 1/10, it might multiply it by 1,000. It's going to do something. There's going to be some kind of factor that I have to have on the left to match the factor on the right. So K times L over 1/4 D squared. So we don't like double fractions, so I'm going to multiply everything by 4. Times L times 4 over 1D squared. Oh, this was my original, but see how there's a times 4 over here now? That means, let's say a car is coming towards you. As their distance cuts in half, their lights are going to appear 4 times as bright. So the brightness is just 4 times as bright. Okay. So let's do something similar. Let's triple the lumens and double the distance. Actually, no, let's triple. Let's triple them both. No, I like double. So we're going to make the light bulb have twice as many lumens, but it's going to move twice as far away from us. So again, we have, what's that going to do to the brightness? If we triple the lumens and double the distance. Okay, so it's getting brighter, but it's getting further away. Well, this would be 3 times KL in the top and 4D squared in the bottom. So, see those numbers right here? To keep it even, we'd have to also multiply this by 3/4. So it would be 3/4 of the brightness. So we can actually use these to go, okay, if I need it to be brighter, if I need it to be this, what happens if I up the lumens? What happens? And we can actually use these variation equations to do these hypotheticals, especially when we're working with headlights where your headlight's on bright versus on dim and how they affect driver's eyes. So you can do them generically, you just have to be really careful to bring that multiplier out to the front so that you can see the effect it has on the right, so that you know it has the same or a different effect on the left. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.